Good morning, everyone. Today we'll be seeing the solution to the problem N triplets, which came in Codechef Starter 72, happened on 4th of January 2023. Alice is still not satisfied with Bob's math skills, so she gave him a new challenge. Given a positive integer n, find any three distinct positive integers a, b, and c, such that the product of any two of these three integers is a divisor of n. The product of all three integers is a multiple of n. If multiple solutions exist, you may print any of them and print -1 if no solution exists. So we are given an integer n and we have to find a, b, c which are distinct and positive such that product of a into b into c is n and product of any two of these is a factor of n. That is a into b is a factor of n, b into c is a factor of n and a into c is a factor of n. So first let us see a hint which is not so intuitive, but very simple and solves almost the whole problem very easily. The hint is that n is both the divisor and the multiple of itself. Because n into 1 is n. N is a multiple of itself, right? And as n divides n is also a divisor of itself. So, first we would see the problem statement more clearly. We are given n and we have to find a, b, c which are distinct and positive such that a into b into c is equals to n and a into b is a factor of n, b into c is a factor of n and a into c is a factor of n. These factor condition proves that n can be prime, n can't be prime, right? As a into b is one factor, b into c is one factor and a into c is another factor. Three factors, n can't be prime. A, B, C are distinct and positive, so A into B, B into C, and A into C can't be C. Yes. So we just take A is equals to 1, and now the problem itself gets solved very easily. If A is equals to 1 and we take B, which is a factor of n, which is not 1, neither n. So we take A is equals to 1, B is equals to B, which is a factor of n, and C automatically becomes n by b as a into b into c is equals to n. So the second condition is satisfied, that the product of all these three is n. Now we have to satisfy the first condition. Since b is a factor of n, then 1 into b is also a factor of n. B into n by b, which is n, is also a factor of n, right? We discussed in the hint. And 1 into n by b is also a factor of n. This is pretty clear, but I would help you to understand this as we take any composite number, let's say 6. Okay, now 3 into 2 is equals to 6. Yes, right. And 2 is 6 divided by 3, right? Or 3 is 6 divided by 2. So if we find one factor, the another factor is right around the corner, which is the quotient. Yes. So n by b is also a factor of n. So 1 to n by b is also a factor of n. Hence the second condition is also satisfied. Now let's go back to the problem statement. We have found a, b, c which are distinct, positive, right? And the product of any three integers, that a into b, b into c and a into c is 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 a factor of n, and the product of all these three integers is equals to n. Now one more case remains. What if we take 4? Now let's take 4. 4 has three factors, right? 1, 2 and 4. Okay. If we take 4 as n, then we have a is equals to 1. Okay. B is equals to n, but again c is also equals to 2. Now the distinct part is not satisfied. That's why when we try to find if n is prime or not, we will also make sure that the factor which we are taking is not the square root of n. Okay, now I think proper explanation has been given, and now let's go back to the C++ implementation of the solution that we discussed. We take the number of test cases and input n, and we initialize the answer as -1. Obviously, if n is neither a perfect square or a perfect square of a prime number or uh, prime itself, then we have an answer. But if the condition is not satisfied, then we have to print -1. So we check from I is equals to 2 to less than square root of n, such that we don't take its square root as one of its factors. If we find any integer which is between 2 and the square root of the given integer, then we print 1, the integer, and the another integer which is the question when that integer is divided by n, that is n divided by answer. If we can't find any such integer, then we print -1. This loop helps us define that if it is a square of a prime number or a prime number itself. If it is not, then we print this answer. If it is, then we print this answer. I hope you are able to understand my solution, and thank you.